All right, neutralization reactions and acid-base titrations. A neutralization reaction is a special type of double displacement reaction between an acid and a base. So here we have an acid, we have hydrochloric acid, and we have a base, potassium hydroxide. Double displacement, the H and the K will switch positions, and then you have to be careful about writing the proper formula for your products. So the H now will go with the OH, HOH, or H2O, and the K will now go with the chlorine, so potassium chloride. When you react an acid and a base, you always produce an ionic compound, we call them salts, and water. We often use solution stoichiometry on calculations for neutralization reactions. Acid-base titrations. So a titration is a technique that we use in chemistry to determine the concentration of an acid or a base, and it uses the neutralization reaction. So a solution called a titrant that has a known concentration is placed in a glass tube called a burette. And a burette is marked, it's measured, and an unknown concentration is placed in an Erlenmeyer flask with an indicator. So basically, you add the titrant until the indicator changes color. And the indicator will change color at an end point. So when you get this color, it's called an end point because it's when you end the titration. You stop titrating. Now, basically, the moles of acid is equal to the moles of base. You've neutralized your solution. The equivalence point is the pH where the titrant, the amount of titrant, the moles of titrant used has neutralized the unknown solution, the acid or base, in the flask. So the moles of acid is equal to the moles of base at the equivalence point. It's a neutral solution. When you pick your indicator, you want to pick it so that your endpoint changes color at the pH at which it is neutral, so at the equivalence point. So a sample problem. This is a typical kind of neutralization question, and this is the foundation behind the calculations in titrations. So in a lab, 0.100 mole per liter solution of sodium hydroxide, so that would be the titrant because we know the concentration, was used to neutralize 450 milliliters of hydrochloric acid, so that is in the beaker. The average volume of base used was 55.3 milliliters. What was the concentration of the acid? So we have a reaction. We have sodium hydroxide plus hydrochloric acid, and this will make water and sodium chloride. So we know we have 0.1 mole per liter sodium hydroxide, and we know we have 55.3 milliliters. So we have to convert that to liters. And for hydrochloric acid, all we know is we have 450 milliliters. So that is 0.450 liters after you do your conversion. And we want to find the concentration. So first I'll show you how to do this using formulas, and then I'll show you using dimensional analysis. Okay, so we can find the moles of our base. We can find the moles of sodium hydroxide because we have both concentration and volume. And that's because concentration is equal to the moles divided by the volume. Okay, so 0.1 mole per liter times 0.0553 liters equals 0.00553 moles of base. Using our mole ratio, we can convert that to moles of acid. And now we can use that information to find the concentration of acid. So the concentration is moles divided by volume. So we take 0.00553 moles of HCl divided by 0.450 liters, and we get 0.01228 moles per liter. We can only have 3 significant digits in our answer, so 0.0123 moles per liter for our hydrochloric acid. So this is like the solution stoichiometry we were doing before. You calculate the moles of one substance, convert it to moles of another using mole ratios, which allows you to find a third piece of information about your substance B. So that is an example of how we do calculations with neutralization reactions using formulas. Now, using dimensional analysis, what I want is the moles per liter of hydrochloric acid. That's the units that we want. I know nothing about moles of hydrochloric acid, but I do have a mole ratio. I know that 1 mole of HCl requires 1 mole of sodium hydroxide. So this way I can get moles of HCl on top. Now I need to get rid of moles of sodium hydroxide, so I can use the concentration. Per 1 liter of solution. And that gives rid of moles. Now, to get rid of liters of sodium hydroxide, I would need to use the liters of NaOH. So now I have just moles, but I do have liters. It's moles over liters, so I'm going to do 1 over 0.450 liters. So 0.1 times 0.0553 divided by 0.450 will give me my concentration of my HCl. And that's how you calculate a typical neutralization reaction using dimensional analysis.